Okay, here's our fourth example in section 5.7 on solving by factoring. We've run through all the different steps on solving by factoring, and we've even talked already about what those solutions mean. When I get an x equals 1 and an x equals 7, what does that really mean about my polynomial? We've talked about that it means that that's where my graph touches the x-axis, right? At x equals 1 and x equals 7, or whatever the two solutions are, right? And so because it touches the x-axis when y is 0, we can find any x-intercept of a graph by taking the equation and replacing y with 0 and solving for x. If y is 0, we can figure out what x is, and then we can figure out where it touches on the x-axis, right? Now when we have a quadratic equation, a lot of times we said, if we have a quadratic and we have an x squared, we end up with two answers, right? Or maybe two x-intercepts. So for example, maybe something that looks like this parabola that touches the x-axis twice. Or maybe it's a parabola that opens upside down and touches the x-axis twice. We've even done one that it has the same solution twice. I think it was an x equals 4 and another x equals 4. So maybe the parabola touches the x-axis once, but it's the same solution. So you still end up getting two answers. It just happens to be the same answer. Now, there are times where when we solve a quadratic, we don't quite get an answer, and so maybe that means it looks like this first one where we don't have any real solutions, where it doesn't touch the x-axis. It's still a quadratic, it still looks like a parabola, we just don't have any real solutions, real x equals answers. All right, let's look at an example. It says in example number 4 to find the x-intercepts of the graph of the equation shown. So it gives us an equation, x squared minus 4x minus 5. And we want to figure out where it touches the x-axis. What are these 2 points right here, right? Well, the graph touches the x-axis when y is 0. You can go left or right, but we don't go up or down at all. We stay on that x-axis. So what we can do is we can take our equation, we can replace a 0 for our y, and then we can solve, just like we've done in the previous videos. We can put everything to the same side, set equal to 0, which it is. We can follow the 7 steps of factoring. To me, this looks like a basic factoring. And then we can set each factor equal to 0, and we end up getting x equals 5 and x equals -1. Well, what that means about my graph is that it touches twice on the x-axis at x equals -1 and x equals 5. But typically those are points, right? They touch at a point, and we always want to write our answer accurately. And so we want to write them, instead of just saying x equals 5 and x equals -1, we want to write them as points. So the first point that it touches at is at x equals 5 when y equals 0, so 5, 0. And the other point that it touches is -1, 0. So make sure when you're talking about x-intercepts, you write them as points, because those are the points where the parabola touches the x-axis. All right. Now that we've done all different types of solving by factoring problems, I have 4 here for you to try. 4 of them. So why don't you pause the video, try these 4 problems where you're solving by factoring, all different types. All right, hopefully you worked through those 4 problems. Looking at number 1, if I'm following the 8 steps, I put everything in order, all to the same side. I'm going to look for a GCF, which it looks like it has a GCF. I can take out an x. That leaves me with an x plus 8. Now that I'm all factored, I can take each factor and set them equal to 0 and solve. I ended up getting 2 answers, x equals 0 and x equals -8. All right, number 2. The first thing we have to do on this one is move the 9 over, so I'm going to add 9 to both sides. Everything's in order to the same side now, set equal to 0, and let's factor. No GCF. It looks like there's 3 terms, so it looks like this is a basic factor problem. Numbers that multiply to 9 that add to 6, I got x equals x plus 3 and x plus 3. So when I set those equal to 0, I end up getting x equals -3 and x equals -3. Now, 2 answers, they happen to be the same answer, but I still do get 2 answers. Remember, this is maybe one of the parabolas that touches the x-axis only once, so maybe its vertex only touches. All right, number 3 is a little bit tricky, be careful. On this one, it is not set equal to 0, so we can't take our factors yet and set them equal to 0. We have to do a little bit of work first. What I suggest you do is probably FOIL that left side, move the 16 over by adding it, and then combine like terms. You should have ended up with a polynomial of x squared minus 6x plus 9 equal to 0. And now we can solve by factoring. It looks like it's a basic factor problem. I ended up factoring it into a perfect square of x minus 3 and x minus 3. So it looks like my solution is x equals 3 twice, right? All right. The last one, number 4, asks us to find the x-intercepts. Remember, that's where the graph touches the x-axis. If we want to figure out where it touches the x-axis, we know that y is 0. So we can take our equation and set it equal to 0, or plug in 0 for y. We can now factor. We can set each factor equal to 0, and I end up getting x equals 3 and x equals negative 2. So maybe my parabola looks something like this. It touches on the x-axis at negative 2 and at positive 3. Now, it asks us specifically on this one for x-intercepts. And remember, x-intercepts are points. So your answer should be written as a point, an x comma y, a coordinate pair. So your final answer really should be 3 comma 0 and negative 2 comma 0 are my two x-intercepts. Now be careful. Don't say 3 comma negative 2 because that's not an x-intercept. Those are two different x answers, not x and a y. So be careful with that. Okay? All right, keep practicing your factoring and your solving by factoring because we have word problems next.